Hey guys, this is Charles from Epic Engineering, and in this video I'm going to do a side-by-side comparison of two versions of UVC lamps. The white one is a low-pressure mercury UVC lamp. The black one is an LED UVC lamp. For sterilization purposes, you can find a lot of UVC products in the market. They're either one of these two types. So in this video, I'm going to test and find out how efficiently they work against the viruses and bacteria. Both of these put out 4 watts of power. The white one runs on 4 pieces of AA batteries, which I have just changed, and the black one has a built-in lithium battery, which is fully charged at this point. So later on when we test these, battery is not going to be an issue. But first of all, we need a standard. In other words, how do we define the sterilization efficiency? And as I went on Wikipedia, I found this. In air and surface disinfection applications, the UV effectiveness is estimated by calculating the UV dose which will be delivered to the microbial population. UV dose equals to UV intensity multiplied by exposure time. Dosages for a 90% kill of most bacteria and viruses range from 2,000 to 8,000 microwatts second per centimeter squared. In this video, I'm going to take 8,000 and put that in the equation at our target UV dose. 8,000 is absolutely not going to kill all viruses and bacteria. As you can see, it's only 90% kill for most of the viruses and bacteria, but it definitely means a good coverage. So the exposure time here is what we use to define the efficiency. The less time it takes to reach our target UV dose, the more efficient it is. To get that result, we need one more value, the UVC intensity, and that's what we're going to do next. We're going to measure the UVC intensity. And the device I'm going to use for the test is this UVC light meter. I've made a video on how it works. You guys can go check it out. We have 2 probes today. These are usually used separately because they're not meant to test the same type of UVC products. One is for mercury UVC lamps. The other is for LED UVC lamps. The question is, why 2 probes? Why not just one? Wouldn't that be much simpler? Yeah, I hope the same. The reason is that these 2 types of lamps all have their best germicidal rays, but they're not of the same wavelength. For the mercury lamp is the 254 nanometers, for the LED is the 275 nanometers. If you look at the spectrum distribution of these 2 lamps, you will see that while the LED puts out a lot of 275 nanometers, it puts out very little 254 nanometers. So it wouldn't be fair to filter out that 275 and say that the LED lamps are not as good as the mercury lamps. So we need to be thorough. That's why we have 2 probes today. And the way I'm going to do this is I'm going to use both these probes on both of these 2 lamps, so we have more data to work with. And also I'm going to collect the data at different sterilizing distances. These are 2, 3, 4, 5 centimeters because these are realistic numbers when we actually use them to sterilize our items. But we're not going to do 1 centimeter because the LED beads are too far apart from each other for our probe to get a good reading at 1 centimeter. Now let me show you what I mean by that. If these 2 get too close, if I place these 2 beads right above the center of my probe, then my probe is going to get more light from these 2 beads and less light from the rest of the panel. So that's going to affect our result because that really depends on how you position your device. So we're not going to do that. And we're also not going to do anything above 5 centimeters because we want to use these as close to the surface as possible. And anything above 5 centimeters is not our concern. We have these blocks here. The way I'm going to do the test is I'll put the probe in between 2 blocks and then I'll put the lamp on top of them. These are 3.5, 4.5, 5.5, 6.5 centimeters tall, and if we minus the height of our probe, which is 1.5 centimeters, that gives us 2, 3, 4, 5 centimeters, exactly what we need for the test. With that said, let's leave both lights on for 5 minutes so that the UVC intensity of these lamps will reach its peak and a steady level, and after that we'll do the test. First of all, we're going to do the the probe for the mercury lamp, so let's plug that in. We don't need to display the energy value. All we need is the UV intensity. And we're going to choose microwatts per centimeter squared. That way it matches our unit in our equation. So now let's start with our mercury lamp. By the way, we're not going to take the average value because that's for when you do an extended period of time. So we're just going to take this value here when it goes steady. Now let's change our probe to the LED. And so, as you guys can see, the result is very, very definitive here. The low pressure mercury lamp wins on both probes. I mean, winning, it's really an understatement here. For the mercury lamp, even though 275 is not where it does best, it still beats the LED by quite a lot. Let's take a look at some of the values here. For example, if we are to take the best scenario of the LED, which is using the LED probe at 2 centimeters, and compare that with the worst scenario of the mercury lamp, which is also using the LED probe, but at 5 centimeters. Now, I understand that this is not by the same standard. I'm just being really nice to the LED here. You'll see that to reach our target UV dose, the exposure time needed for the low pressure mercury lamp at 5 centimeters is almost half that of the LED at 2 centimeters, meaning the efficiency is almost twice. Again, not by the same standard. And you guys can compare all these numbers any way you want. And we're not even talking about other germicide arrays that the mercury lamp is capable of putting out, but LED lamp barely puts out. because the germicidal range is from 200 to 300 nanometers. And that is something that you guys can think about.